Assalamu alaikum. We are going to start our today's lecture, and attendees are 37. That is good indication. So our lecture is starting. Let me show the lecture notes, sharing the screen. Yes, influence lines and moving loads for statically determinate structures. We know that the shear force and bending moment diagrams show the variation in shear force and bending moment respectively along the span of beam for a particular location of static load. Static load is underlined because the shear force and bending moment, conventional shear force and bending moment diagram correspond to the static loads. Now the main objective of drawing of shear force diagram and the bending moment diagram is to know that where the value of the shear force and bending moment is maximum along the span and what is its value which will be used for design purposes. Now if you look at this diagram, this is a simply supported beam subjected to a central load P. Of course, the reactions are equal P by 2 and P by 2. This is the bending moment diagram having the maximum ordinate PL by 4 because when P by 2 will be multiplied with L by 2, it will be PL by 4. So now from this diagram, we can see that it will be the bending moment will be 0 at the support, then it is linearly increasing to the maximum at the midpoint, and the maximum value at the midpoint is PL by 4. That is the purpose of drawing of bending moment diagram. Now with this little background, we start the influence line. These lines have important application for the analysis of structures which are subjected to large moving loads like bridges, industrial crane rails, conveyor belts, etc. When these structures are subjected to moving load, the variation in reactions, shear force, and bending moment along the span is best described by using influence lines. Now, firstly, you have to understand that influence lines are drawn where the moving loads are dominant. They have more impact than the dead loads. Secondly, these are drawn for knowing the variation in reaction, shear force, bending moment, and so on, even for displacements. Now, the main objective of drawing the influence line diagram is where to place the moving load, because now load is not static, it is moving, continuously moving. Now where to have the moving load along the span to get the maximum effect of the force. एक दफा फिर आप इसको समझ लें, where to have the moving load along the span of the beam to have the maximum value of the force, reaction, shear force, or bending moment. First is to determine the critical location. Then second is, and what is its value for design purposes. I think objective is clear to all of you. Now it has two steps. Now it has two steps. First is drawing off influence line diagram for a unit moving load. In all the cases, whether it is a case of reactions, whether it is a case of shear force, whether it is a case of bending moment for beams, for girders, for trusses, this step will remain the same. This step, rather both steps will remain the same. First step is drawing of influence line diagram for unit moving load. The influence lines are drawn by placing a unit moving load by considering it at any location, at any time, location X from the support. However, for academic purposes, we will assume that moving load moves from right to left. Practically, it can be moved from any direction to any direction, but for academic purposes, we will assume that moving load moves from right to left. Now, after drawing of influence line diagram, the second step is determination of critical location of actual moving load. Where to place the moving load to have its maximum impact. Determination of critical location of actual moving load, and this will be done either by trials or by judgment or by the combination of both, or as a last option by using mathematical criteria, where it will give the maximum effect of the force. Then computation of the value of that force. These are the two steps. Now let me know if you have any confusion regarding these two steps. Any question? Your proper understanding from the start is extremely important. So it is clearly understood. Where is the CR? Yes, Mr. CR, you are available. Anybody else? Is it clearly understood? आप इतने खामोश क्यों बैठे हुए हैं? बिल्कुल आपको ऐसे साफ सूंघा हुआ है आपको. So now the next is types of moving loads. We have mainly two types. One is the concentrated load. Those are the wheel loads. And second is uniformly distributed load. Under this category, we have one is shorter than the span, like tank loading, like the military tank loading. Then the longer than the span, like procession loading, जो जुलूस निकलता है. There are some standard wheel loadings. One is the standard truck loading, having 3 wheels spanned by 4 meter and 4 meter. ये distances change नहीं हो सकते. These cannot be changed because just imagine that the distance between two wheels of one side of a vehicle cannot be adjusted. उनका distance जो है वो कम या ज्यादा नहीं किया जा सकता. आपकी अगर मोटर बाइक है, मोटरसाइकिल है, तो क्या जो दोनों व्हील्स के दरमियान फासला है वो आप प्लस माइनस कर सकते हैं? नॉट एट ऑल. So these distances are fixed and these loads are fixed. Then we have standard train loading having total 18 meter span, and these two loadings you have to remember. Then we start the influence line diagrams for reactions. The first one. Of course, the first step is drawing of influence line diagram for unit moving load. Look at this beam. It is again a simply supported beam, support A and support B. Now this unit load P moves from B to A, from right to left. Let at any time interval, it is at a distance x from support B. And surely from support A, it will be L minus X because the total span of the beam is L. So these are two reactions, RA and RB. Now, how we are going to proceed? Now for RA, for this reaction RA, our normal practice is take the moment at B. Take the moment at B. For any location x of unit moving load P from right to left, sigma MB is equal to 0. Now what we will get? RA into L minus PX is equal to 0. This is our routine calculation. We get RA is equal to P into X over L. Now this X over L, we call it influence coefficient. A first degree equation, a first degree expression. P is the unit, that is 1. Now, when X is equal to 0, it means this unit load is at B. Using this same equation, RA will be 0. यही इक्वेशन यूज करनी है और डिस्टेंस आपका x कहां से वेरी कर रहा है? 0 से L तक. When x is equal to 0, that means unit load is at B. RA is equal to 0. Similarly, when x is equal to L, that means unit load is at A. RA is equal to 1 using the same equation. Now you have to mark these 2 points. ये दो dots आपको नजर आ रहे हैं, 0 and 1. Now you have to join these 2 points with a straight line. Why straight line? Because this expression is first degree expression, which always correspond to a straight line. And it will always be straight line because now mark these 2 points and join them with a straight line. The resulting shape is the ILD for RA because this is the linear function of distance x. Similarly, for RB, sigma m is equal to 0, जिस तरह हम reaction निकालते हैं. Now, RB into L minus P into L minus X is equal to 0. Now, RB we will have P into L minus X over L. Now, this L minus X over L is called the influence coefficient. It is again of first degree expression. Similarly, when x is equal to 0, That means moving load is at B. RB is equal to 1. When X is equal to L, moving load is at A. RB is equal to 0. Now again, you have these 2 points, 0 and 1. Mark these 2 points and join them with a straight line. The resulting shape is the ILD for RB. Any question, any confusion as far as the drawing of these two influence line diagram is concerned? ये साथ साथ चीजों को क्लियर करते चले जाएं ताकि आगे चीजें जाके आपके लिए प्रॉब्लमेटिक ना हो. जी, any confusion? Okay. Now using these two influence line diagrams, now we can compute the maximum reactions for any real moving load. And that is step 2. Step 2. Compute the maximum reactions for following moving loads. A. 50 kilonewton single load and B. Standard truck loading. Now there are two, span is 10 meter. That this span is 10 meter. Now there are two aspects. Where to place the moving load to get its maximum effect or value. And second aspect is computation of that value. Now there is one guideline. ये भी आपको अपने जहन में इसको पेस्ट करना है. And that is based on simple mechanics. Moving load, the guideline is, ये हर एक के लिए एप्लीकेबल है, शीयर फोर्स के लिए भी, बेंडिंग मोमेंट के लिए भी, एंड ऑनवर्ड. The guideline is moving load should be placed in such a manner that heavier loads be multiplied with the bigger ordinates. और ये गाइडलाइन है फॉर व्हील लोड्स. अब अगर ये जो ऑर्डिनेट है, जो हाई, ये मैक्सिमम ऑर्डिनेट इसका 1 है, इसके साथ अगर स्मॉलर लोड मल्टीप्लाई होगा तो वो आपको मैक्सिमम वैल्यू कभी नहीं देगा. लिहाजा जो आपके हैवियर लोड्स हैं, जो लोड है, that should be multiplied with the bigger ordinate. That we will see in trials. So this is done either by trials or by judgment or by the combination of both trials and judgment, and that is the most effective. Or lastly, by using the mathematical criteria. Now let's proceed. When moving load of 50 kilonewton moves over the span, RA will be maximum when 50 kilonewton load is at A, where ordinate is maximum. अब देखें यहाँ पे ऑर्डिनेट RA के लिए मैक्सिमम है. जब 50 किलो न्यूटन लोड इधर आएगा तो मैक्सिमम वैल्यू आएगा. इससे पीछे कहीं पे भी उसकी जो पोजीशन होगी वो वैल्यू नहीं आएगी जो इस ऑर्डिनेट पे आएगी. दिस इज वेरी क्लियर, वेरी कॉमन सेंस की बात है ये. Simple is that, so that value will be RA max 50 into 1 is equal to 50 kilonewton. Very simple. And similarly for RB, when the 50 kilonewton is at B, where the ordinate value is 1. So RA and RB will be 50 kilonewton. However, for standard truck loading, we have to make trials. First possible जो इसकी trial है वो ये है कि the first wheel should be placed at A. when the standard truck loading moves over the span. Let's do the trials for learning point of view. Otherwise, it can be done very simply with the judgment. When wheel one is at A, the biggest ordinate will be multiplied with the smallest load. So it will be, अच्छा अब आपको एक और चीज जो बतानी है, the value of ordinate at A is 1. The slope of this line is 1 over L. Always ये जो भी चीजें हैं ये आगे भी सेम ही कॉन्सेप्ट चलने हैं. Slope is 1 over 10. Now the ordinate corresponding to this load, इसका डिस्टेंस B से 2 मीटर है. So it will be 2 by 10. इसका डिस्टेंस जो है 2 plus 4 6 मीटर है from B. It will be 6 by 10. इसका 10 मीटर है, it will be 10 by 10 or 1. So by this way, with the help of slope and with the help of horizontal distances, these ordinates will be computed. So the first trial, when the wheel 1 is at A, 16 into 1 plus 64 into 6 over 10 plus 64 into 2 over 10. This will be 67.2. Now let's make second trial. When the wheel 2 is at A, surely this will give the maximum value, and this 16 kilonewton will be out of the beam. So now 64 will be multiplied with 1, and this 64 will be multiplied with 6 by 10. Trial 2. Wheel 2 is at A. RA 64 into 1 plus 64 into 6 by 10. That is 102.4. Similarly, make the third trial when the third wheel is at A. These two wheels are out. So third trial says that 64 only. So the RA will be maximum when wheel 2 is at A, and its value is 102.4. जी यहां तक किसी को कोई कंफ्यूजन, कोई क्वेश्चन आपका? That is the procedure applicable everywhere. Either we will be going through these trials, such trials, or we will be directly going by judgment. If you have any question, you can ask at this stage. Any confusion? Feel free to ask.
सर ये ट्रायल वन
जी?
का दोबारा बता दीजिए सर.
किसका जी?
ट्रायल वन दोबारा बता दें सर. ट्रायल वन
देखें बेटा, ये आप ये डायग्राम देखें. RA, अब ये है V, ये हमने स्टैंडर्ड ट्रक लगाया ऊपर, ठीक है. यहाँ 16 इन ये है, इसके कॉरस्पॉन्डिंग ऑर्डिनेट 1 है. दिस 64 का जो कॉरस्पॉन्डिंग ऑर्डिनेट है वो 6 by 10 है. इस 64 जो थर्ड व्हील है इसका कॉरस्पॉन्डिंग ऑर्डिनेट 2 by 10 है, ठीक है. और ये ऑर्डिनेट कैसे आने हैं ये भी मैंने आपको बता दिया है, विद द हेल्प ऑफ दिस स्लोप and these horizontal distances. Just multiplied this horizontal distance with the slope. So now trial 1 will be 16 into 1 plus 64 into 6 by 10 plus 64 into 2 by 10. जी समझ आ गई आपको?
जी सर ठीक है.
अच्छा, अब यही ट्रायल अब आप जब आप व्हील 2 आगे ले जाएंगे ए पे, तो व्हील 1 तो बीम पे नहीं होगा. यही 64 into 1, और ये तो तीसरा व्हील है, ये 2 वाली पोजीशन पे होगा, ये 64 into 6 by 10. और थर्ड ट्रायल में ये जो आखिरी व्हील है ये ए पे होगा, 64 into 1. आपको कुछ नहीं करना सवाए ऑर्डिनेट निकालने के और ज़रब देने के. ये ILD जिसको समझ आ जाए उसके लिए ये इंतहाई आसान है, इंतहाई आसान है। इसमें कोई कॉम्प्लिकेशन है ही नहीं है। ये सिंपल लाइनें ड्रॉ करना और इकाई के कायदे के साथ कैलकुलेशन करना है, नथिंग एल्स। अब यहां तक के काम को आप मुश्किल कह सकते हैं? द ओनली थिंग इज टू हैव प्रॉपर अंडरस्टैंडिंग। Similar procedure will be done for wheel for RB. Again we will, इसमें भी, इसमें खैर हम डायरेक्ट जजमेंट लगा सकते हैं, आप ट्रायल करना चाहें तो कर सकते हैं। ट्रायल 1 क्या होगा? That doesn't make any sense when wheel 1 is at B. Trial 2, wheel 2 at B, and trial 3, which will give the maximum value, trial wheel 3 at B. Because now you can see that इस अरेंजमेंट में इसकी मैक्सिमम वैल्यू आएगी, क्योंकि अगर आप व्हील 2 रखेंगे तो एक हैवी लोड बीम से बाहर होगा। दैट, असल में इसमें आपकी जो एक कॉमन सेंस और जजमेंट है ना, ये इसका बड़ा वाइटल रोल है इसके अंदर। ये उसी तरीके से है कि आप में से जो मोटरसाइकिल की राइडिंग करते हैं, ड्राइविंग करते हैं, रात के टाइम उनकी जो हेडलाइट होती है उसकी बड़ी लिमिटेड एक्सेस होती है, लेकिन उसके अंदर रात की ड्राइविंग के अंदर से कि आप 80 की स्पीड पे जा रहे हैं, जो आपकी हेडलाइट की बीम है वो उस स्पीड के मुताबिक उतनी दूर तक नहीं जा रही होती जितनी दूर तक आपको देखने की जरूरत होती है। बट उसके साथ आपकी जो एक जजमेंट जो ब्लेंड हो रही होती है उसका बड़ा वाइटल रोल है। द सेम सिचुएशन इज हियर। Your common sense and judgment must be fully functional. That is, that must be fully functional. अच्छा देखें, अब आप इसी को बीम्स इनको जरा मूव करें ना जरा। व्हील 1 को बी पे रखें, आउट ऑफ क्वेश्चन किसकी मैक्सिमम वैल्यू है। व्हील 2 को यहाँ रखें, आउट ऑफ क्वेश्चन इसकी मैक्सिमम वैल्यू है। Yes, wheel 3 will give you the maximum value. So you can directly write that by judgment. It is evident that RB will be maximum when wheel 3 will be at B, and start doing the calculation. This load 64 into 1 plus 64 into 6 by 10 plus this 16 into 2 by 10, and that's it. So I have done here, RB will be computed in the similar manner by judgment. It is very clear that RB will be maximum when wheel 3 is at B, keeping in view the above guideline. वही जो bigger loads हैं that should be multiplied with, जो heavier loads हैं that should be multiplied with bigger ordinates. So RB 64 into 1, 60 plus 64 into 6 by 10 plus 16 into 2 by 10, that will be 105.6 kilonewton. Alternatively, we can make the trials if judgment cannot be done. So इसमें कोई आपकी confusion है तो बताएं मुझे, कोई question है तो बताएं। जी कोई क्वेश्चन आपका?
नो सर।
चले, शुक्र है जी। अब हम चलते हैं यूडीएल की तरफ कि जब यूडीएल का मामला हो, then how to compute the, how to proceed for step 2. Step 1 will remain the same. When moving load is UDL, beam is same. UDL, first case is UDL shorter than the span. Let's this UDL having a span of 5 meter with the intensity of 4 kilonewton per meter. This ILD is same. Now the criteria for maximum effect for UDL. UDL should be placed over the beam span such that the area of ILD, the area of ILD under UDL be maximum. आपने इसको उधर प्लेस करना है जहां पे ILD का एरिया अंडर द UDL जो वो मैक्सिमम हो. Look at this first case for RA. Let it be for RB first. Now, if we place the UDL here, the area of ILD under UDL will be max. इसकी किसी भी और पोजीशन पे, क्योंकि मूविंग है, इसकी किसी भी और पोजीशन के लिए area under the UDL, area of ILD under the UDL will not be maximum. Now, how we can compute the value of that reaction? That is the intensity of the UDL into area of ILD under UDL. और ये किसका माइक खुल गया भाई? Similarly, for RA, we have to place. यार ये किसका माइक खुला हुआ है? भाई किसका माइक खुला हुआ है? ये इसको बंद करें.
मैं पिछड़े ना कुछ तो तेरी कॉल ही कोई नहीं हमको ना अल्लाह ने बातें कॉल पाए होगी
कौन शख्स है ये?
बहुत कुछ जवाब है मसला है ना मैं जितने कुछ जवाब रखी टीम में मतलब फुटबॉल टीम मैं ना कबड्डी ना रेडर हो क्रिकेट बता राउंड हो फुटबॉल ना खुद फॉरवर्ड है मैं प्लेयर साडा वन डाउन करते काम ले कुत्ती पैवनी मंदिर को नहीं बना नहीं ये कुत्ती अल्लाह पाक नहीं कोई जोड़ा है ये भी तो मां दो पैर करनी हां
So presently I have muted all. I will unmute after some time because that irresponsible student was not closing his mic. So the area of trapezoidal, now this is a trapezoid. The area of a trapezoid is equal to half into sum of the parallel sides. These are two parallel sides into horizontal distance between the parallel sides, that is 5 meter in this case. So in both the cases, RB is equal to RA max will be equal to 4 into half plus 1 into 5, that is 15 kilonewton. Now what we will do when the UDA is larger than the span? In this case, we will place the UDL over the entire span and compute the reactions in similar manner. UDL outside the beam span will not be considered. Now let me unmute. अभी unmute किधर से होंगे?
सर अनम्यूट हो गई है, ये आपकी स्क्रीन ब्लैक नजर आ रही है सामने से।
जी अभी आपको लेक्चर नोट्स नजर नहीं आ रहे?
सर अब क्लियर है।
जी अब बताएं कि इसमें यूडीएल के केस में कोई क्वेश्चन है आपका?
नहीं सर, फिलहाल समझ आ गई है।
चले, दैट्स गुड। सो
अ, सर
जी बताएं।
सर मैंने पूछना था कि जब ट्रक जो है उसके सारे व्हील्स आ जाएं उस बीम के ऊपर, मतलब लोड अगर आ जाए तो सर वो यूडीएल बन जाएगा ना?
अल्लाह के बंदे, ट्रक यूडीएल कैसे हो सकता है? उसमें टायर नहीं लगे होते?
जी सर, टायर तो होता है। नहीं
फिर
लेकिन
तुम
सर
मुझे
उसका
बता।
सारा लोड तो आ जाएगा ना उसके
ओ
ऊपर
नहीं ओ
अगर
भाई,
सारे उसके।
उसका उसका सारा लोड जो है, अब तुम जस्ट कंसिडर योर सेल्फ, यू आर ए यूडीएल और यू आर ए कंसंट्रेटेड लोड।
मैं कंसंट्रेटेड हूँ सर।
तुम्हारा सारा वजन तो पाँव के जरिए से जमीन पे जा रहा है,
जी सर।
तो फिर तुम यूडीएल क्यों नहीं हो?
सर मैं अपनी सेंस में अगर देखूँ तो पॉइंट लोड नहीं बनेगा।
भाई वी लोड्स दे आर पॉइंट लोड्स, ये
ओके
तो
सर।
बड़ी बेसिक चीज है। यस, तुम अगर किसी रोड पे लेट जाओ तो फिर शायद तुम यूडीएल बन जाओ, लेकिन खड़े होने की पोजीशन में यू आर ए कंसंट्रेटेड लोड।
ओके
सो
सर ठीक।
ऑल व्हीकल्स एक्सेप्ट द टैंक, वो टैंक भी व्हील्स वाला नहीं, वो चेन वाला, वो यूडीएल है। व्हील वाला जो टैंक होगा वो भी व्हील लोड होगा, कंसंट्रेटेड लोड होगा। जी, एनी अदर क्वेश्चन about this UDL?
नो सर।
So now we take up the case of an overhang beam. Now the portion AB is similar to the previous one, but the portion AC is the overhang portion. Now the purpose of teaching this overhang beam is that the slope of this influence line will not change. It will go straight. So this ILD for RA between A and B is exactly the same what we have drawn in case of simple beam. This is the overhang portion AC having the span of 5 meter. This will go straight, and this ordinate is computed, this total distance divided by the horizontal distance. This is the 15. So 15 divided by 10, so 1.5. Alternatively, we have seen that the influence line is a linear function of distance x, so it will always be a straight line, same slope. In case of overhang beam, x is 0 to a plus l. This is l and this is a. Using the same influence coefficient for RA, we have RA P into X over L. When X is equal to 0, moving load is at B, RA 0. When X is equal to L, moving load is at A, RA is equal to 1. When X is equal to A plus L, moving load is at C, RA is A plus L over L. That is 15, 1.5, sorry, 1.5. So marking and joining these points with a straight line will give the ILD for RA. This is step 1. For RB, this was the coefficient, influence coefficient for simple beam. Same influence coefficient is here also. When X is equal to 0, moving load is at B, RB is equal to 1. When X is equal to L, moving load is at A, RB is equal to 0. When X is equal to A plus L, moving load is at C, RB is minus A over L. Marking and joining these points with straight line will give the ILD for RB. Note, if the overhang portion is on both sides of the beam, procedure of drawing of influence line diagram will be exactly similar. G, as far as the drawing of ILD for overhang beam is concerned, any confusion? Step 2 को भी बाद में डिस्कस करते हैं.
No,
अच्छा, now we have to compute maximum reaction for standard truck loading. Again, either trials will be made or location will be decided by judgment, where the wheel will give the maximum value. Keeping in view the judgment, the guideline, judgment says that now this is the wheels of the truck. Now first wheel at C will not give the maximum value. Now there are two options. Let me share with you. Some books says that any wheel should be at that reaction point. Some wheel should be at that reaction point. And some books says that no, that may not give the maximum value. So the wheel must be at the biggest ordinate in case of overhang beam. So I prefer both can be adopted. Both can be adopted, but I prefer the second one, that this is more realistic and this will give more value than the earlier approach. So RA will be maximum when wheel 2 will be at C, where the ordinate is the maximum, that is 1.5. So this ordinate, this is 4, which is fixed. And because this distance is 5, so this will be 1, because the total is 5. So 10 plus 1, this ordinate will be 11 by 10. So 64 into 1.5 plus 64 into 11 by 10. This will give us 166.4. Now similarly, for RB max, we have this arrangement. When wheel 3, it's the same as the previous case. RB will be maximum when wheel 3 will be at B. And surely the value will be same as of previous. Yes, the same one. 64 into 1 plus 64 into 6 by 10 plus 16 into 2 by 10. That is 105.6. Now this is another beam having span of 12 meter. We have to compute the maximum reaction for standard train loading. This is the standard train loading. Now as far as the drawing of ILD is concerned, for unit moving load, same approach. ILD for RA and RB are drawn for unit moving load as usual. जो हमने जो exercise की है, the same one. This slope will be 1 by 12. This is 1. 1 by 12 and 1. Step 1 is same as of previous. No change. Now step 2, computation of RA max and RB max. Either trials are made or judgment is applied or the combination of both, keeping in view the guidelines. अब इसमें अकल का काफी इस्तेमाल है. This span is train का total span 18 meter है. If you count 2 plus 2 plus 2 plus 9. 9. 2 plus 2 plus 2 plus 3 is total 9. Then this 2 plus 2 plus 2 plus 3, 9. 9 plus 9, 18. So this is the maximum ordinate. Of course, this total span is 12 meter. I think for you, it's more convenient to go for trials because you have to learn the things. First, surely it is the half load 60 kilonewton. First wheel at A. This cannot give the maximum value. So you can start from wheel 2. Wheel 2 at A. Surely this will give by judgment, this will give the maximum value of the reaction. So we have to place the wheels like this, wheel 2. Then at a 2 meter again, wheel 3, wheel 4, wheel 5. Then at 3 meter span, wheel 6 of 80 kilonewton, wheel 7, and this remaining, this 2 plus 2 plus 2 plus 3, 9 plus 2, 11, and this will be 1. So the corresponding ordinates 1 over 12, 1 plus 3, 3 over 12, then 6 over 12, 8 over 12, and 10 over 12. These are the ordinates. Now simply multiply these load with the corresponding ordinates. You will get the value of RA max. So it is very clear that RA will be maximum when wheel 2 is at point A. That is by judgment. So RA simply 120 into 1 plus 120 into 10 by 12 plus 120, 8 by 12 plus 120 into 6 by 12 plus 80 into 3 by 12 plus 80 into 1 by 12. This will come out 386.64. Similarly, for RB, it will be more convenient to make some trials starting from wheel 5 at B and then wheel 6 at B. ट्रायल भी आपने blindly नहीं करने, sensibly करने हैं. And if you do the trials sensibly, you will reduce your mathematical work, computation work. So when trial 1, when this one, wheel 5 जो है वो B पे है, wheel 4 here, again similarly the ordinates are computed with the help of slope and horizontal distances. So trial 1 will give us 375 kilonewton. Trial 2, when wheel 6 will be here. Wheel 6 will be here. So wheel 6 जो है वो अगर आप देखें तो वो 80 किलोन्यूटन का है. Wheel 5 120 किलोन्यूटन का है. So wheel 6 at B will give us RB value of RB as 320 kilonewton, which is lesser than the earlier value. So wheel 5 will give us the maximum value of RB. जी यहाँ तक आपकी कोई confusion, कोई question है, have a break of 5 minutes, then let me know if you have any question, any confusion till now. You can ask so that then we will proceed ahead.
हाँ सर.
इसका मतलब है आज आप सुपर स्पीड से जा रहे हैं.
सर असल में चीजें थोड़ी बहुत आइडिया समझ में आ रहा है. जब हम सर मतलब और प्रैक्टिस करेंगे तो चीजों पे ग्रिप अच्छी होगी.
नहीं देखें, बरखुरदार बात ये है कि अब आपका एक काम है कि इसकी मैक्सिमम प्रैक्टिस करें. जितनी प्रैक्टिस करेंगे उतनी ग्रिप आपकी बेहतर होगी. यहाँ तो चीजें आप कंसेप्चुअली समझ रहे हैं ना. अब आपकी
जी
प्रैक्टिस से ग्रिप होगी।
जी बिल्कुल सर।
सो अगले 2-3 मिनट में पानी शानी पी लें, तो फिर हम 2-3 मिनट के बाद इसको फिर रिज्यूम करते हैं।
जी बेहतर होगा सर।
So resuming our lecture after short break. Now these points 0 and 1, 0 and 1. These are called key points. These are called key points. Now, one method of drawing of influence line diagram for unit moving load was by basic approach. Now, the second option is method of key points. How to draw the ILD for unit moving load using key points. We have seen that the value of RA was 1 when the unit moving load was at A, whereas RA value was 0 for moving load at other support. This is the conclusion. Again, listen it. We have seen that the value of RA was 1 when the unit moving load was at A. For all other position of the unit moving load, the value of RA was 0 at other supports. Similarly, value of RB was 1 when the unit moving load was at B and 0 at other support points. Since the influence line is a linear function of distance x always, so joining above points called the key points with a straight line will give the required ILD. This method of key points, we directly mark the key points. Then we will join these points with a straight line. This method of key points is usually more convenient for statically determinate multi-span beams or compound beams. वहाँ पे वो सिंपल जो अप्रोच है, बेसिक अप्रोच है, वो उतनी वर्केबल नहीं रहती, because this method of key point is also based on the basic approach. So we will directly mark the key points, then we will join them with a straight line. Now, another more powerful technique of drawing the influence line diagram is based on principle of virtual work. You might have studied this virtual work. अगर नहीं पढ़ा तो that's I can upload this principle. In this approach, we give a unit positive displacement. We give a unit positive displacement at the location where the ILD is to be drawn for the required function. Actually, they are all interrelated. Method of key point that is based on the basic approach, and this giving a unit positive displacement that is also linked with method of key points. So giving a unit positive displacement at the location where the ILD is to be drawn for the required function, whether it is reaction, shear force, or bending moment, and 0 at all other supports. Now, marking and joining all these points with a straight line will give the required ILD. Now we will see its application. This is a compound beam, two-span beam. Without this hinge at D, it is indeterminate by 1 degree. Now, by introducing this hinge at point D, the indeterminacy has been removed. Now it is statically determinate. So using any of the above two methods, we have to compute the maximum reaction for standard truck loading for the given beam. Beam has been made determinate by introducing hinge at the point D. Now step 1. ये अभी आप जो ग्रीन कलर में लोडिंग है इसको इग्नोर कर दें. Now, one thing more, which is new for this kind of beams. Now, as far as the continuity is concerned, this beam has two portions, portion A, B, and D. Any function will be continuous. जो इस रीजन में कंटिन्यूस होगा दैट विल बी कंटिन्यूटी जो उसकी होगी वो डी तक होगी. उससे आगे उसकी कंटिन्यूटी नहीं होगी. कंटिन्यूटी हिंज पे, इस हिंज पे जाके ब्रेक हो जाएगी. दिस इज ऑलवेज, जहां पे भी हिंज आएगी वहां पे उसकी कंटिन्यूटी ब्रेक हो जाएगी. नाउ दिस वी विल लर्न इन स्टेप 1. नाउ ड्राइंग ऑफ influence line diagram for unit moving load when the load is at a r is equal to 1. ये हमने पॉइंट यहाँ पे लगाया. सबसे पहले हमने ये डॉट लगाया. ग्रेजुअली आप देखें वी हैव mark this point, key point at A, 1, when the load is at, and 0 at all other supports. अभी आप इस लाइन को भूल जाएं. Only this key point at A having the value of 1, 0 at all other supports, 0 at B, 0 at C. 1 at A, 0 at B, 0 at C. I'm again repeating, 1 at A, 0 at B, because वहां पे भी सपोर्ट है. 0 at C वहां पे भी सपोर्ट है. और थर्ड ऑप्शन में वी हैव गिवन ए यूनिट पॉजिटिव डिस्प्लेसमेंट. अपवर्ड जो है रिएक्शन पॉजिटिव हम लेते हैं. सो वी हैव गिवन ए यूनिट पॉजिटिव डिस्प्लेसमेंट at A and 0 at all other supports. 0 at B, 0 at C. So now we have to mark these points with straight line. So A और B जब दोनों हम मिलाएंगे स्ट्रेट लाइन के साथ, so ये स्ट्रेट लाइन जाएगी D तक. D से आगे नहीं जाएगी. यहां इसकी कंटिन्यूटी ब्रेक हो गई. यहां पे 0 है C पे और उसकी कंटिन्यूटी है D तक. सो 0 और ये D तक आएगी. ये समझ आती है बात आपको? एनी कंफ्यूजन?
सर डी पे सपोर्ट लगी है तो डी पे उसकी कंटिन्यूटी ब्रेक नहीं होगी क्योंकि डी पे
इस क्वेश्चन को दोबारा पूछें जरा.
सर अगर बी पे सपोर्ट लगी हुई है तो फिर हमें तो बी तक लाइन ए से बी तक स्ट्रेट लाइन जानी चाहिए, तो हम डी तक क्यों एक्सटेंड कर रहे हैं उसको? ये समझ नहीं
देखें, आपकी ये लाइन जो डॉट्स आपने लगा दिए ए पे 1 पे, बाकी दो सपोर्ट पे 0 पे. अब सवाल ये बाकी रहता है आपने इसको ज्वाइन कैसे करना है. ज्वाइन करना है स्ट्रेट लाइन ने. स्ट्रेट लाइन कहां से कहां तक जानी है? ए से बी तक तो सीधी आ गई. आगे ये जाएगी डी तक, वहां तक ये फंक्शन कॉन्टिन्यूस है. वहां तक ये फंक्शन कॉन्टिन्यूस है. हिंज पे जाके कॉन्टिन्यूटी ब्रेक हो जाती है. ये आप पल्ले बांध लें या कहीं लिख लें. हिंज ऑलवेज ब्रेक द कॉन्टिन्यूटी. यहां तक ब्रेक हो गई. अब ये लाइन नहीं है. यहां पे आपका जो की पॉइंट है वो 0 है. What option you have now? और इसकी C और D की जो है C भी कॉन्टिन्यूस है D तक. The only option is to join C with this point. अभी भी समझ आता है कि नहीं आता आपको? क्योंकि इस लाइन ने डिस्कनेक्ट कहीं नहीं होना. इस लाइन ने डिस्कनेक्ट कहीं नहीं होना. ये नहीं होगा कि ये ऊपर चली जाएगी लाइन. So now marking and joining these points with a straight line will give the required ILD for RA. Inference line is a linear function of distance x and continuous up to hinge. portion ABD and CD with respect to continuity. Similarly, अब इस पे भी आधा देख लें. B के लिए है तो B पे इसका जो ऑर्डिनेट होगा 1, बाकी सपोर्ट्स पे 0. So you have now 3 key points for ILD for RB: 0, 1 and 0. Or alternatively, you have given a unit positive displacement upward at point B and 0 at all other supports, 0 and 0. Now how to join them? 0 to 1, straight line. This will go straight up to the hinge. This is 0. This will be joined with this point. This is the ILD for RB. ये मेरा ख्याल है आपकी थोड़ी सी ज्योमेट्री भी मुझे वीक लगती है. ये ज्योमेट्री में भी इस किस्म की चीजें होती हैं. Anyhow, as far as the slopes are concerned, this slope is 1 by 10. If this is 1 by 10, this side slope is also 1 by 10. And this ordinate under the hinge is 2 by 10 because this distance is 2 meters. Now this slope will be this slope divided by this distance, 2 by 30. Simple geometry. Similarly, 1 by 10, 12 by 10, and this ordinate divided by this horizontal distance will give the slope, that is 12 by 30. Now, any question regarding this first step?
No, sir.
Now, step 2, computation of maximum reaction. Either trials can be made or by applying judgment. Now, here it is very simple to apply the judgment that RA will be maximum when wheel 2 is at A. इसमें तो कोई confusion हो ही नहीं सकती. So 64 into 1 और इसके जो corresponding ordinate है, अगर ये 4 मीटर है और टोटल 10 मीटर है तो ये 6 मीटर होगा. So 6 by 10. So RA max 64 into 1 plus 64 into 6 by 10, that is 102.4 kilonewton. So अभी RB के बाद में चलते हैं, पहले RC की तरफ चलें. RC में देखें, आपने यूनिट पॉजिटिव डिस्प्लेसमेंट दी C पे और 0 at all other supports, 0 0. So 1 0 and 0. ये जब 2 0 मिलाएंगे तो ये इसकी कॉन्टिन्यूटी जाएगी हिंज तक और फिर ये वाला पॉइंट ये इस 1 के साथ ज्वाइन होगा और इसकी स्लोप 1/3 होगी. It is again very simple to judge that RC will be maximum whether you place wheel 2 at C or wheel 3. Both will give the same answer. So that will be 64 into 1. 64 will into 1, that is the RC max. Now RB. Now here we have to little use more common sense that RB will be maximum when wheel 3 is at A. This is the judgment. Wheel 3 is D. Wheel 3 is at D. Yes, the biggest ordinate. So 12 by 10, then 2 meter, 2 meter, 8 by 10, then 4 by 10. This will give us RB max 16 into 4 by 10. plus 64 into 8 by 10 plus 64 into 12 by 10, that is 134.4 kilonewton. Alternatively, trial for wheel 2 at B can also be made. That will give us 99.2 kilonewton reaction. This is much less than 134.4 kilonewton. Now, the same beam, for the same beam, compute maximum reaction for standard train loading. अब ये जरा आपने खुद काम करना है, ठीक है? For I have given the answers and the guideline. Check for wheel 3 at A. RA max will be 301.33. For RB max, check for wheel 4 at B or wheel 5 at D. RB max will be 450 kilonewton. For RC max, check for wheel 3 or 4 or 5 at C. RC max will be 160 kilonewton. So, अब हम चलते हैं how to use mathematical criteria. At the end, you will conclude that trial and judgment is the best option. So, mathematical criteria for determining the critical location of moving load in step 2. If trials or judgment or combination of both is not working, then the third option is to use mathematical criteria. In this criteria, we compute the gain and loss in reaction for each advancement of the wheel load as follow. The gain in reaction is equal to GA over L, and the loss in reaction is Pn. What is G? It is the sum of wheel loads on the span after advancement, where A is the advancement distance, the distance between two consecutive wheels. Pn, the wheel load which has advanced. L is the beam span. Now, as far as GA over L is greater than Pn, that means as far as the gain in reaction is greater than the loss, reaction will keep on increasing, and we have to check for next advancement of the wheel load. Now, the wheel which reverses this condition, is the wheel when placed at the maximum ordinate will give the maximum reaction value. Let's apply this criteria for computing RA max. Same beam for standard truck loading, giving first advancement of the wheel 1. देखें ये 3 व्हील है, आपने फर्स्ट एडवांसमेंट दी और ये व्हील 2 इस बीम से बाहर गया और व्हील 2 इस ए पे आ गया. Now the wheel which has been advanced, that is Pn, that is 16 kilonewton. A advancement distance is 4 meter. Span is 10 meter. So GA, the sum of the wheel loads on the span, 64 plus 64. Now GA over L, 128 into 4 over 10 is equal to 51.2, which is greater than Pn, which is 16. It means gain is more. So we will proceed for next advancement. And that is wheel 3 is at A. This wheel is at A. In this case, Pn is 64. जो wheel advance हुआ है next step में वो 64 kilonewton है. A is again 4. G is now 64 क्योंकि अब बीम पे सिर्फ 64 kilonewton का लोड मौजूद है. Now GA over L is 64 into 4 divided by 10, that is 25 by 25.6, which is less than the Pn. Pn is 64. It means this wheel will not give the maximum value of the reaction. So it means कि किस व्हील ने ये सिचुएशन चेंज की है, किसके जाने से ये सिचुएशन चेंज हुई है, व्हील 2 के जाने से ये सिचुएशन चेंज हुई है. So we can conclude that wheel 2 when at A will give the maximum reaction, and that is this value जो हम पहले भी compute कर चुके हैं. That is just to show how to apply the mathematical criteria. G, any question?
No, sir.
So then we proceed for our last beam. This is again a multi-span or compound beam having 2-degree constraint, which has been eliminated by introducing 2 hinges at D and E. Now again, as far as the continuity is, or continuity of the function is concerned, it has 3 spans, A, B, C and D. जो भी इसमें फंक्शन होगा वो D तक कंटिन्यू होगा. फिर ये है GFE, जो भी इस पोर्शन में जो फंक्शन होगा वो E तक कंटिन्यू होगा, एंड DE. इसको क्लियरली समझना जरूरी है, तभी आप कंफ्यूजन से बचेंगे. So method of key points or principle of virtual displacement. Now this is RA for this is the ILD for RB, giving a unit positive displacement at B and 0 at all other supports. पहले आपने सिर्फ पॉइंट मार्क करने हैं, ये वाले की पॉइंट कह लें. 1 at B, 0 at all other supports. यहाँ पे भी 0, यहाँ पे भी 0, यहाँ पे भी 0, यहाँ 1. This is the first step work. पॉइंट आपने मार्क कर लिए, या आपने यूनिट डिस्प्लेसमेंट दे दी B पॉइंट पे और 0 at all other supports. अब only thing is how to join these points with straight line. Now join the point B with point C with a straight line. This will go straight up to A. This will go straight back up to D. Because in this portion, the continuity of the function is intact for this portion. So this straight line, now portion GFE, 0, 0 जब आप दो लाइनों को मिलाएंगे, it will go up to E. Continuity E तक है. ये यहाँ तक आया, ये यहाँ तक आया. Rest is join this point. These 2 points. How simple it is. Now, as far as the slopes are concerned, this is 1 by 5, this is 1 by 5. This ordinate is horizontal distance 3 meter hai, 3 by 5. This slope is 3 by 5 divided by this horizontal distance 2, 3 by 10. Similarly, ILD for RC. Now we have to give a unit positive displacement at C and 0 at all other supports. 0 at B, 0 at F. यहाँ RE की बजाय RF लिखना चाहिए था, इसको अब RF कर लें. It's not RE, it's RF. So 0 at F and 0 at G. Now simply join these 2 points. These 2 points. Now this line will go straight back up to this point A and straight go up to point D. This is a straight line. with the slope 1 by 5 and 1 by 5. The ordinate at C is 1. The ordinate at point D is 8 by 5 because this horizontal distance is 8 meter. Now these two 0, this will continue up to this point E. Now these 2 points will be joined with this straight line. Now this slope, this is 2 meter. So this ordinate divided by 2, that will be 4 by 5. Similarly, ILD for RF. Give a unit positive displacement at F, 0 at G, 0 at C, 0 at B. So 1, 0, and these two zeros. So join this 1, the point at F with point at G with a straight line. This will go up to this point E. Now these two zeros will be continue from point A to point D. So these two points will be joined with a straight line. This slope is 1 by 5. This is 1. This is 8 by 5. This slope is 8 by 5 divided 2. That is 8 by 10. And lastly, ILD for RG, giving a unit positive displacement at G, 0 at all other supports. 1, 0, and all other 2 zeros. This is continuous up to point E, 1 by 5, 1 by 5, 3 by 5, and 3 by 10. So using the method of key points or technique based on method of virtual displacement, the ILD for RB, RC, and RF and RG are drawn for unit moving load. Now, step 2 for the first for standard train truck loading. ये ट्रक लोडिंग पहले नंबर पे आपने करनी है. ये सेकंड स्टेप पे आपने ट्रेन लोडिंग करनी है. सो आई हैव गिवन द पॉइंट्स RB max for standard truck loading, wheel 2 at B, RC wheel 3 at C, D, for RF wheel 2 at E, and for RG wheel 3 at G or 2 at G. These will be the answers. Then for standard train loading, you have to make the trials starting from wheel 2 at A, then wheel 3 at A, and so on. Our C-max start trials from wheel 5 at D. Hopefully this wheel when at D will give the RC max. Similarly, other 2 trials you have to make. Now, these you have to do at your place by yourself, and you will send these numerical problems by Friday, and thus you can email by Friday. So if you have any question, so next time on Monday, we will start the influence line diagram for shear force. So before that day, you must go through these notes, must grip these all points, because if you don't have the grip on today's lecture, you will face the difficulties in next lecture. G, any question? G, if you have any question,